We're going to be looking at a topic called probability.
When we talk about probability, we're talking about the chance or how likely it is for an event to occur. Let's take a look at a scale to help us learn some vocabulary before we really get started. Here's a probability scale. I like to draw it like this because it helps me visualize what each of these words mean. You'll notice that there's two words on opposite sides of the scale. There's impossible and certain. Impossible means that that event can't happen, and certain means that it has to happen. So let's take for an example a regular dice. It has 6 sides and it has numbers 1, 2, 3, 4, 5, and 6. If I roll that die, it is impossible for me to roll a letter. I'm not going to roll it and it's going to roll an A. It can't happen. It's impossible. Certain means it has to happen. So in the same way, if I roll that same dice, it has to roll a number. It's certain that it will be a number. It might be 1, 2, 3, 4, 5, or 6, but it's certain that it will roll a number. Also inside of my scale are the terms unlikely, equally likely, and likely. Let's take a look at a spinner to help me explain those 3 terms. When I look at this spinner, I see 3 colors, green, blue, and red. You'll notice that they're all different sizes. When I think about unlikely, I think about a color that I can spin, but is smaller. So if I look at this spinner, I see that green is the smallest section, making green unlikely for me to spin. But blue is also a really small piece. It's bigger than green, but it's still less than half. So blue is also unlikely for me to spin. But if I think of the color yellow, there's no yellow on this spinner. So yellow is impossible for me to spin. So when I think about the word unlikely, I'm looking for a color that's less than half of my spinner. Here's another spinner. This one looks kind of funny because you have such a huge section that's green and then a section that's red. When I think of the word likely, I need to think of this type of spinner. You'll notice that the majority of the spinner is green, or more than half. When more than half of the outcomes can be a certain event, it's more likely or likely. So on this spinner, we're likely to spin green, and it's unlikely for us to spin red, since red is less than half of the spinner. Here's a third spinner. This one is our equally likely spinner. You'll notice that it's split exactly in half. That means it's equally likely to get yellow, and we're equally likely to spin on blue. Equally likely means I have a 50-50 chance of that outcome happening. Let's look at the spinner and do a few practice questions together. We need to be careful as we're reading each of the questions because just a few letters can change everything about what they're asking. So let's read the questions carefully. The first question asks, what is the probability of the spinner landing on a 3? So let's look carefully at the spinner. How many pieces have a number 3 in them? Only 1. So there's only one little section that gives me a chance of landing on a 3. It's not impossible. I could land on a 3, but I don't have a very big chance. So that means that this is unlikely. I don't have a big chance, but there is a small chance. The next question asks, what is the probability of the spinner landing on a 1? Well, when I look, I see that there's 2 1s. Still, there's not a big chance. It's not the whole section. It's not a large, more than half. So it's still unlikely that I'll land on a 1. Then it asks, what's the probability of landing on a 2? Again, there's only one little teeny tiny piece, making it unlikely that we'll land on a 2 as well. The fourth question's a little bit tricky, so let's read it carefully. Are you more likely to spin on an odd number or an even number? Well, let's remember, odd numbers we have 1s and 3s, and for the even numbers we have 2s and 4s, and there's 3 of each. If I think about a circle and I split that circle in half, there's 3 sections on each side. So if there's 3 and 3, it's equally likely that we'll spin on an odd or even number. Let's try this example with counters. The directions say Emily placed 8 counters, like the one shown below, in a bag. She selected one counter from the bag without looking. Which color counter is she least likely to select? Notice that they even capitalized it, so we know that we're looking for least likely. So I'm looking for the color that has, well, smallest number of chances. I start by looking at each of the colors individually. I see that there's 3 blue circles, 2 red circles, 2 gold circles, and only 1 pink circle. So the least likely is going to be the one that has the least amount of circles or counters. So in this case, pink is the least likely because there's only 1 chance of getting pink. Here's a new type of question. Again, let's read the directions carefully. All the cards shown below are put in a box. Sheena picked one card from the box without looking. Which of the following best describes the chances that the name on the card she picks begins with a letter A? Well, if I put all of those cards in a box, I look, and if I first look at all of the cards, every single name starts with A. So what do you think the chances are? If you said certain, you'd be correct, because no matter which name I pull out, it has to begin with a letter A. And if it has to, it's certain.
One of the things I like to caution my students about when it comes to probability is not letting your imagination run away from you. When asked if, can bubblegum fall from the sky like rain, is that certain or impossible? Be careful not to think, well, there could be this one time. When we're talking about probability, we're talking about what can happen in a normal, ordinary day. So if you're asked, can Miss Brown turn into a watermelon? I don't want you to think, well, can I imagine Miss Brown turning into a watermelon? Because yes, you can imagine that happening. But can Mrs. Brown turn into a watermelon on a normal, ordinary day? No, that would be impossible. Unless I was a bit emoji. But again, not letting my imagination run away with me. Good luck, and I hope that you enjoy learning about probability this